We have seen the architecture of a computer. We have a central processing unit here. The central processing unit has a control unit, the arithmetic logic unit. You need a memory unit for storing both programs and data, and then some mechanisms for communicating the computer with the outside with input devices and output devices. That is a computer. And we are used to see computers made of silicon chips and electronic components. But as soon as we are able to create logical gates here, or gates, and gates, not gates, working in binary, we will be able to create a computer. So for example, in this video, you will have some of the basic components of a computer made of wood and some mechanical components. For example, this will be a NOT gate. Okay, you can see you have some rubber, you have some wood, and with that you are creating a logical gate. So combining lots of these logical gates, you will at the end you will be able to create a computer. You have here some more examples. An OR component. Okay, you have here, this is an AND gate, and combining them here you have another. For example, this will be a circuit for adding two binary numbers. Okay, and you have more examples here. For example, this is a full computer working with metal balls and some other components. Here you have a better picture. This is the memory, for example. Here you have more components. This is the address decoder for the memory. And you have another example. This is another. This kind of a structure made of some pieces made for building blocks for kids or something like that. This mechanism is able to add some numbers. Of course, you won't be able to create a full modern computer using this kind of techniques, but they are very useful only for researching and for playing with the computer concepts. But what will happen, what we can do is to use a computer. Okay, remember that we only need to reproduce logical gates working with binary. We can use a real computer. Okay, this will be a computer with the computer we know today, with the screen, the keyboard, the silicon chips and whatever. And then we can create a program, and this program will emulate the logical gates of a computer. So in fact, we are creating a computer inside a computer. So here we can create a chip, some instructions, get some memory, and all this will be done not by wood, not by kid toys, not by metal bolts, but with a program running in a computer. So in fact, we are creating a fake computer inside of which is running inside this computer through a program. This is called virtualization, and we will be using it today. We will be using it in this course because it will be very useful when learning concepts about operating system. What we are doing in the course is to create this kind of fake computers here. So we can configure them, we can perform file operations on them, or we can install operating system on them. So our real computer here won't be affected. So for example, if we made a mistake installing an operating system or working with a hard drive, formatting something, removing files, this computer will be the one which would be affected. But our real computer will keep working. And also we can have an operating system here, and here in the computer is a different computer. It's an emulate computer, but a different computer. We can have a different operating system. So here, for example, we can have Windows, and here we can have Linux, which is the operating system we will be working most in this course. So this is the concept of virtualization, creating a computer inside a computer, and we will use this in the course for working safely with the operating system we will work.